He's just doing some really interesting technical stuff that I'm going to have to take the time to do it to process. Russell Kay, the CTO of Yo Games, graces us with his presence to talk to us about some of the tricks that he's learned over his many storied years making games. Hopefully I'm going to learn a lot from him, and I reckon you all will too.
All right. Okay, thank you, Julian. Yes, so we're going to talk about some classic techniques, particularly for Fire game development. Jesse's exited here, so there you go. So yeah, no, we have announced, yesterday we announced that we have a particular Fire module. It is a nice, easy way to get into game development. It means that you get, for 60 days, you get the free Amazon Fire module. Little hint, if you've not got a Fire, you can get them on Amazon for £50, which is a really cheap way of getting an Android development kit. Basically, a Fire device is an Android device. So Amazon Fire will get you onto its mobile really quickly. And it also means that all the trial limits of GameMaker disappear and you can still test things on your Mac or Windows device. Okay, so for the IDE, so it's also 60-day free. You also lose all the limits for trial. So you could try out GameMaker Studio 2 full version there, okay? But you can't make executables for those particular platforms. You can only do it for Fire. So anyway, that's the little pitch there. It's kind of start off with. So content, so I'm going to talk a little bit about who I am and then go through all these different things. I'm afraid that this is a technical talk, okay? Technical's in my title here. It's what I do all day. So hopefully, it's going to be a little bit like a fire hose. We're going to go through it relatively quickly. You can ask me questions at the end, unless you put up your hand and say my brain is full, okay? Okay, so who am I? I am a founder member of DMA Design, which is a company way back in the day. I actually started off at events a bit like this. So we had every Thursday in Dundee, we had a meetup of people who were interested in computers to start off with, and there was a good group of us that were all just interested in games. There were some people who wanted to play games, and other of us who actually wanted to take them apart and find out how they actually worked and what they actually did. Out of that, Computer Club was formed, DMA Design, and we went on to do quite a few games that you may know. So I was involved doing Lemmings, Lemmings 2, Grand Theft Auto on PlayStation 1. I went on to do Formula 1 on all the consoles from Sony and from EA, and then on did Harry Potter, Medal of Honor, and then ended up at CTO Yo-Yo Games. So I've been doing this for 30 odd years, straight from school, got into games and all the rest of it, and I have been applying that experience to what we do at Yo-Yo Games. So I have been doing a lot of this stuff over the years. So why classic techniques? Well, you see, while computers these days are much, much faster, I mean, a Spectrum was 3.5 megahertz speed-wise. That means it could do, every instruction was at least 4 or 5 clocks. So that meant 3.5 megahertz. You're doing much less than 1 million instructions a second. These days, these devices, I'll fish around in my pocket and pick up my iPhone. These devices are about 1 billion times faster than that was, and yet it still has the same sort of problems. We still end up with same issues, and so classic techniques that we used way back then are actually still quite applicable. While the CPU is really fast, the battery just means that you've not got an awful lot of oomph that you can use all the time. You're wanting to spread things out. You're wanting to do a similar amount of things. Graphics are quite specialized. They're a wee bit quirky. They're a wee bit sort of different. Everything's really relative about these things as to, they might be much faster, but you've got similar problems, okay? Similar scales of things. So I'm going to talk a little bit about that. I'm going to use example projects. Angry Cat Space, it was made in GameMaker. It was actually, it's kind of one programmer, one artist, spent a couple of days using the physics. It was something we made quite a while ago now. We used to go to GDC a lot and have a stand there, and we had things that we'd actually go and show. So this is one of the projects that we did. It's inspired by other it's kind of particular games. You may see that, but there's nothing special going on here. I'm actually going to get this put up on Marketplace as a project that you can download as a demo. It's kind of very simple. We've got the other one, which is actually ships with GMS2 at the moment, which shows how to do a little isometric tile map type thing. Nice and easy, shows lighting, shaders, that sort of stuff. Comes in 2 flavors, one with shaders, one without shaders. So you can use it on the trial edition. I'm going to use both those to actually do that. So caching graphics. This is something that GameMaker does in the background. So that's a little bit of a backgrounder as to what GameMaker is actually doing for you. Moving data around inside the computer is actually quite expensive. Okay, so moving all those graphics, so we've got this great ability to draw graphics, nothing like the Spectrum was, but it still takes a lot of time to actually get that to the screen. The cost of doing it as separate images, which is the way we would have done it in things in the past, is kind of quite high. On the RAM and VRAM and texture swapping, these things are all expensive. Collating all the graphics together into a single texture page is a really good idea because it means that you're using the GPU hardware well, and you're also saving on RAM and VRAM and that sort of thing. So you can do this in one of two ways. There's statically or dynamically. When we do it statically, we can do quite a lot of optimizations because we've got a lot of time. It's relatively. The best optimizations that we can actually do are where we eliminate what you don't need. So one of the things that we do in GameMaker is we trim all your graphics down. We take away all the space around outside, which is great. As an artist, you want to move things around, that sort of stuff. That's fine. As programmers, we only want to draw the actual pixels that you're actually going to render. We maintain the offsets and things like that. So as far as the author is concerned, as far as the artist is concerned, it's still positioned in the same place. It just means that we're using less space. We also do things like, if you use the same image, so sometimes you might want to slow an animation down or something like that. So if you duplicated the frames, in GameMaker, we will actually only store that frame once. And so every frame, we actually go through and we actually go, okay, we actually calculate a hash code for the programmers out there to actually go, okay, this hashes to this. If we see the same hash, we'll then check that those graphics are actually the same. And if they're actually the same, we'll just reference the same graphics. So we'll only put that down once. Okay, so as artists in GameMaker, you can duplicate frames all over the place, no extra cost. Okay, very little overhead. We gather all the images together in GameMaker. You can use texture groups. If you put things in texture groups, then we will gather them together into single texture pages. Now, texture groups can have parents. Okay, and what actually happens is a texture group has a bunch of settings that you can actually do. You can tell it to crop extra space or to not crop extra space. You can drop things out per platform, so you can have graphics that are only going to appear on iOS, graphics that are only going to appear on Android, that sort of thing. Whoops, hang on. And parents, if your texture group has a parent, they will all try to put them onto the same texture page. Okay, if there's more graphics than can fit on a single texture page, it will create multiple pages, but it'll still try to group things together. Okay, so it's a little top tip that you can use texture groups and parents and things like that to do a lot of selective stuff, drop out graphics, but also it means that you can collate small groups of things together that are logically together, but they can be collated into one large texture page. Okay. Another thing that we do that you can make within GameMaker as well is to dynamically create your own texture pages. Generally, though, the compression is a lot less aggressive. Tend to use slots. We use this for fonts. If you use font add and give it a TTF, we use a dynamic sort of texture grouping mechanism to actually collate all the glyphs together. So this is the sort of thing that you'll end up with, where we've cropped its edges and things like that. This is all the graphics for Angry Cats. That isn't actually any empty space there. There's actually alpha graphics and things like that going on across here. This is a font. There is some extra stuff inside here as well. When you actually look at that with Photoshop with alpha on, then you can see that sort of stuff going on. But we have quite an aggressive thing where it's actually fitting things between gaps that it finds in the, it's quite efficient, the texture packer that we've got inside GameMaker. Of course, we end up with two things. You don't just have that set of graphics, there's also what's called the texture atlas that goes along with that. Inside GameMaker, you can find that. It's inside your cache. You can actually read it out. It's just a bit of XML, and you can hook into that at that point. So another thing, of course, is organization-wise, something that we do in GameMaker Studio 2 quite a bit. We like layers. Layers is a great way of organizing things. Back in 8 and 16-bit days, we had what we called playfields. They were all done with hardware. They were basically layers in which you can actually do things. Now it's much better. You're not limited by the hardware, and we can have lots of layers going on. But this is good. We use it in the room editor. We also use it in the image editor and things like that now as well. And layers are a good way of organizing things. So here's a little demo of the different layers going on inside GameMaker Studio 2. So in Angry Cats, there's a background layer, there's cloud layers, the front here, there's it's Moon, and then there's the actual gameplay layer. So this is the room editor, Studio 2. You can move things around, you can rotate things all nice and easily, zoom in, zoom out, switch on and off the grid, that sort of thing. Manipulate these objects. These are all it's kind of instances in this case here. And here's a video of once we've actually done that, then you can see the game just kind of kicks in and all the kind of physics starts happening at that point. Okay, that's all well and good. That's all nicely organized, but we've actually got our game running. And one of the major things that you do inside a game is allocate things. So if you're doing a shoot 'em up, you might have lots of bullets. If you're doing like a gauntlet type game, you've got enemies coming out, you've got sort of generators, that sort of thing, and you're doing lots of object or instance creation. The problem with that is that there's quite a lot of instance create, for example, in GameMaker, has quite a lot of overhead on it. Okay, it's creating dynamic objects. There are some good ways of doing this. Dynamic object creation has a really bad CPU profile, right? Because there's lots of memory gets moved around, there's lots of preparation. In the case of instance create, we actually have a complicated mechanism going on in the background for making sure objects are sorted in the right way and are created in the right order. And the insertion sort that really goes on there is quite expensive. So you don't really want to do that too much. There's a system called pool allocation, which is much better, and it's really easy to do. I'll talk you through. So the whole idea of pool allocation is create either all your objects up front or create a lot of them up front so that you take the expense and you put them at the very start of your room creation. So here's a little bit of code here. Does a create, just does a DS list create, and then creates all the instances, sticks them in there, and then you deactivate the instance. Not got that bit of code up there, but you just deactivate the instance. Inside the allocate, find the free objects, and then put them into, make them not free, basically, and return the actual object. So when you want to allocate that object, just find it in the list, and then when you come to free it, just set the free flag to be true again. So that would actually kind of bring it there. You'd obviously have to actually activate the object at that point in time. The other way, if you don't want to activate and deactivate the objects, then you could also just hide them off screen, essentially. Basically, if an object's off screen in GameMaker, right, it will get clipped. It's not really good. If you've got nothing in the step event, then it's not going to actually process. Okay, so they're quite cheap. So a better way to do that, you see, the thing we didn't like there was the allocation. You're actually doing a search. That's bad, right? Doing a search all the time is bad when you come to pool allocation. Much better way of doing things. I have to say, I didn't come up with this myself. Mike Daly did, who sends his apologies. He's at his wrestling thing again. He wrote this up for Game Programming Gems. It's in chapter 4.5. Not sure about the 0.5 bit there, but it's called stack allocation. And basically, the idea is here, let's use a pool. Okay, that's a good idea. But instead of just having the pool, let's create a stack of indices for free objects. Okay, so when you come to allocate something, I want an object, you just pop the index off the stack. It's a stack of free objects, and so if there's something on the stack, pop it off. There you go. That's a free object. I can just go and use that. If you want to free the object, you just push it back on the stack. Very, very simple. Stacks are dead cheap. Very, very simple to it. And We actually use this a lot in the background of GameMaker. It's when we're actually creating instances, sorry, when you destroy an instance, we don't actually get rid of the memory for it straight away. We put it into a pool. If we require memory, we will free everything that's in that pool. If we don't require memory, then we'll just reuse the object next time you come along to do an instance create. So we are actually using this mechanism internally in GameMaker. So the create is a little bit more complicated because we create the list of objects and we create the stack. Okay, and the stack is just indices into that list. When we come to the allocate itself, we just pop the index off the stack, return that. There you go. That's the object. When you come to free it, then just push the object back on the stack. Dead simple, very easy to go and do. And you can even do this inside inner loops and things like that, and it really doesn't come into the profile. It can be used for lots of things. Doesn't have to be. It's kind of graphical things. We use it. I've used it in the past for AI objects, for particles, for all sorts of things. It's very good. So tile maps, as you all know, GameMaker Studio 2, we've gone all out on tile maps as proper tile maps, not what we used to call tile maps back in it's kind of GameMaker Studio 1, but a proper tile map where it is just an array of entries, an array of it's any size, doesn't have to be square. So when I say m by n, I mean it could be 20 by 3000, 3000 by 6000, anything that you actually want. It just comes with a texture entry for each one. Sorry, a tile map entry for each one. Tiles themselves come from a single texture, so it's your tile maps and things like that. This is exactly what we're talking about. All the graphics for a single tile and a single layer. There is some gotchas, particularly for 1.x, if you're using this sort of stuff, where we've got written up in our blog post to do with the sort of GPU rendering. We fixed most of that in GameMaker Studio 2, so that's not really applicable for that, but it is something you've got to watch if you're doing any of your own rendering. So this is a dungeon demo. This is using lots of tile maps and lots of layers so that you can control the order which are actually going to get drawn. Got a little video here. So you can switch on the visibility. You can start to see so the tile roofs and the instances themselves, different items that are on the. It's much better to organize things when you've got the names and your level designers can actually organize the actual levels. It's much easier. So it's got the floor, the water, they're all different things. We have got built-in auto tiling in GameMaker 2 so that you can create your auto tile maps. Jesse was using that as well. Robert was alluding to that. And we can also do all the animations and things like that too. You can set up animation sequences for different tiles, and it renders really fast. Can't emphasize enough, tile maps are a really good way, very efficient in actual rendering. There's lots of tricks that we can do. I'm going to go into a few of them in just a minute. So a tile map entry. A tile map entry, if you're rendering this yourself, you could do anything that you wanted for a single tile map entry. In GameMaker Studio 2, we use 32 bits. That means it's only 4 bytes per entry. It's not very much. It's quite efficient. But you can do lots of different things with that. We allocate bits within. If you dial down into GameMaker Studio 2, we've actually allocated masks and ways in which we can actually do these things. You have control over some of these bits yourself as to what you can actually do. You can talk to me afterwards. The scope of that isn't for right now, but if you're interested in that, I think we use 2048 as a limit at the moment. We can expand that later on, but we use other bits for flipping X and Y directions for tiles, and so that you don't have to have all the various combinations in different situations. We also allow you to, so that's flipping X and Y. So flip X would just give you a mirror that way. Flip Y gives you a mirror on that. Flip X and Y, and well, you do the math. It's exactly what that would look like. You can get most of the rotates out of doing flips X and Y, but you can't get them all. So we also allow you to rotate. Obviously, if you use a non-square tile, some of those rotates are going to look wrong. So if you're wanting to use rotate, then please use a square tile. Otherwise, you're going to have a lot of headache otherwise. while we don't do this now, it's coming, but palette entries for each tile map, you will be able to have the same tile, graphical tile, but different colors applied to it within the actual tile map. So there you go. That was official new feature that I'm announcing tonight. Andrew will kill me later. So anyway, yeah, it's not coming for a few versions yet, so don't get too excited. Okay, we've got most of it working. Another great thing you can do with tile maps is that it's great for collision purposes. You don't have to use tile maps for showing things that are going to be displayed to the user. You can use them for hidden information, for AI, for waypoints, for collision, that sort of thing. Tile maps are easily indexed. They are very simple. That's the equation up there. You can get your Y, you divide, you do a % mod on it with the M of the M by N that we're talking about, and you have a map stride is simply how many things across the way that it actually is, okay? Plus X modded by N as well, right? So it's very, very simple. And you can easily index straight into the tile map. We give you a couple of functions to do that. Tile map get at, pixel, and tile map get at all do these things. So here we're using a different collision type, different graphic type for each collision thing, and you can use this for AI and that sort of stuff. I'm aware of time, so it kind of looks a bit like this. If you get our dungeon demo, this is what we do here. There's a collision layer, and on the collision layer, we're using a particular tile set, and that tile set is actually saying whether or not the player can walk into the wall or whether it's water. And that's all it's actually doing. That's the only two types that we actually got. We used a system exactly like this for Lemmings, where we had a tile map that was just used for the collision layer, and that said whether or not there was the blockers were standing there, so blockers had collision attached to them, and also whether things were made from metal and you couldn't actually cut into them, that sort of stuff. So it's exactly that sort of mechanism. So anyway, there you go, and it's great from a debugging point of view, because you've now got a layer there that you can actually switch on and off with a hidden debugging key. So you can go, oh, right, okay, so what's that actually look like? So you can check against what the level designers have done. It also helps for programmers to then go around to the level designers and go, you put that in the wrong place. Stop that. Mike did have a version of this where he was actually putting collision on the treasure, so you could pick up the treasure. So that he could actually just kind of put that down. So you can add in all sorts of different meta information to this as well. So that's great, but sometimes you want to do something that's a little bit more advanced. Tile maps are really easy to render on the GPU. Those of you who've done shaders, you can do all sorts of things. If you store your tile map, it's 4 bytes. That just sounds like an RGB and an A there. Okay, so for those of you who've done any of that stuff, then you can actually attach a second texture to the second sampler, and you can, inside your fragment shader, you can actually sample from both the tiles and the tile map at the same time, and you can render these things properly. So I've got a little example of actually doing that. Again, this was Mike. This is something that he did where he's taking a tile map, does all the animation. This is all being rendered inside a fragment shader, okay? And then because the textures can wrap and things like that, then it means that you can do a variety of different effects, all just coming from the fact that it is rendering using the GPU. Once you've got it in the GPU, you can do all sorts of things. Because while we think of things linearly, once you can do all sorts of things with the actual GPU, and you can start to distort, stretch, and generally manipulate your image. So you don't have to render them just across the screen like you normally would. You could actually use the vertex shader and start to move things around and have your shader doing lots of interesting things. If some of you may know maddening, and things like that. We used a technique similar to this to actually it's when we did it for consoles and things. We took it and manipulated as just a general tile map and start to render it differently. If you know Geometry Wars and things like that, that's what the guys did. But that was just a normal tile map, but then they had gravity effects happening and things like that to distort it. You can do all sorts of localized things like that within the actual vertex shader. And I would really emphasize that you can start to do a lot of interesting stuff when you start to move things onto shaders and get some really nice effects. And of course, we support that across platforms now in GameMaker. Okay, so rapid development. I think we can skip a lot of this. You guys know all about how quick it is to actually do things in GameMaker. It's kind of, this is a talk that I did yesterday at the Amazon App Store event. But it's basically just a quick video just to show GameMaker Studio 2. Hit and run on, it's kind of there for Angry Cats. Of course, it goes away and compiles it. Here it's compiling to the VM. You can see it says up there, gets the game running. There it's doing all the packing, all the graphics. When GameMaker's compiling there, it's doing that all the time. It's actually doing the compression and eliminating all the things that are the same, that sort of stuff. Here it's doing HTML5, so we've not made any changes. It's now compiling it to JavaScript, and it's then going to start Chrome and then loaded everything, and of course it's working. So there's a little bit of variation on how to play Angry Cats there. You don't always have to go over the top. You can go on to the bottom there. And then, of course, Amazon Fire. There we go. We're actually got it. So that's an Amazon Fire tablet across here. And then it shows you how quick it is. Once you've got the SDK and everything installed, it's very simple to set up. Sean actually put a video up I think it was yesterday or today. I noticed that on Twitter, where he's talking you through how to actually set this up. And it really is nice and simple. There we go. You can see that we've got the cable attached here, and that's just attached into the Fire device. This works from PC or from Mac. And there you go. You got it's kind of touch enabled, so that you can play your game. So there we go. That is my talk. You see it, and I'm not a pro, so I've not got a last slide either that has anything there. So sorry, Jesse. So, sorry. Yeah, it's a good tip. It's a good tip. So there you go.
We don't need the public service.
Exactly. Yeah. So if you've got any questions, I'll be somewhere around the back at the end. I'll pass over to Julian.
Grand.
There you go.
Thank you very much, Malcolm.